Alright people, we've got a video here about the Monty Hall problem. The Monty Hall problem, right? So, of course, it can be pretty counterintuitive. And I remember when I learnt about what it was, I couldn't get my head around it at all. And one of these days I was like, I'm just going to sit down and do it physically and see if I can understand it. And when I did that, I realised, I think there's a way of explaining it that's quite intuitive, right? So, I'll just try and show you it now, okay? So, the way I see it is, it's easier if you can actually see all the prizes, you know, so you don't need to picture it. I think once you can, in the original challenge, all the prizes are behind closed doors, right? So you need the probability seems very abstract, but I think if you can just see it in a transparent way, it becomes very obvious how it works, right? So instead of the goat in £1 million, right, we're just going to have a £1 and 2 pennies. So obviously the pennies are the shitty prizes, right? So instead of them being behind doors, we'll just put them where you can see them, right? So the 2 pennies are going to go in a can, 2 cans of Coke, right, half cans of Coke, and then the pan, we'll just slip it under a transparent glass, all right? I mean, it would be better if we had them all under glasses, really, but anyway. So how it works, obviously, you go to the game show, and the game show host says, right, we're going to give you a chance to win £1 million, right? Or, if you don't pick the right door, you win a goat instead of £1 million, right? So, 2 of them have got a goat, and 1 of them's got £1 million. So, I'm sure you know, if you're watching the video, you probably know the challenge, right? So, they say to you, just tell me which one you're thinking about, and you pick one at random, right? So let's say, for example, you pick this one, and then the game host says, right, you've picked that one, just don't pick it yet, don't reveal it yet. What we're going to do is, we're going to show you one of the ones that is definitely wrong out of the other 2, right? So, you've picked one, say C, right? A, B, C, pick C, okay. So you put that to one side. Out of the other 2, at least one is a booby prize, right? It might be that you picked the correct one or the wrong one, but it's 2 wrong ones, right? So at least one of the other doors, as far as you're concerned, because you can't see it, remember, in the original, at least one is wrong. So the game show host says, I'm going to reveal one of the other doors, and it will be a booby prize. So you've picked C, right? So he says, we're going to reveal this one. As you can see, it's just a penny, right? So that's a booby prize. Now, so you know, you've picked this one as a hunch, and you know this is a booby prize. So obviously you don't know, you can't see. We know, so this one you know for a fact is a booby prize because the game host tells you. These other 2, you don't know, right? You just know you picked this out of hunch, and this was not the one that he revealed, or she revealed, right? So then, the mathematical thing is, the game host says, right, this was your hunch. Would you like to stay with your original hunch, or would you like to go with the third option and change? So, would you like to stick or change to the other option? And then the question is, does it make any difference probabilistically which one you choose? So obviously it's very counterintuitive that it would make a difference. It feels like it's 50-50 chance, right? You got one who's been revealed as a booby prize. There's 2 booby prizes. So now you know there's 1 good one and 1 booby prize, but you can't see which one's which. It feels like it's exactly 50-50, and it don't make any difference. It shouldn't make any difference which one you picked as a hunch. But as you probably know, mathematically, you should always swap. So why the bloody hell does that work? It doesn't make any sense, does it? Why is it that if you pick one at random, the game host reveals one of the booby prizes, how does that affect whether or not you pick the right one in the first place? And if it doesn't affect it, why does it make any difference which one you pick? Which is an excellent question, and that's why it's so counterintuitive, right? So, let me show you the way, in my opinion, is the easiest way to think about it, in my opinion, right? So, the way I see it is, right, there's exactly 2 strategies, and that's what it's really about. It's a game of 2 strategies. There's exactly 2, right? Not less, not more. There's exactly 2 strategies, right? The first strategy is you pick one out of a hunch, and then when you're asked if you want to stay or swap, you stay. That's the first strategy. The second strategy out of two is you pick one out of a hunch, and then you're asked if you want to stay or swap, and you swap. Those are the two strategies. That's it. That's the only decision you make in the whole game, is whether or not to swap. There's two ways of playing the game. So you're still wondering, why does it make a difference to the probability? Well, let's just play it out, okay? Now, I know that I put the pound under the glass, right? So it sort of makes it look a little bit special. But you know what? In fact, I'm going to change that now. Just say, don't think I'm prejudiced. Right? Put the pound in one of the random ones, right? So let's play the game. Oh, tangled up. We'll put the pound here though, because it's easier to show. So the game host says, pick one at random. A, B, C. Let's say you pick A as a hunch, right? So you picked A. Now pick it. Game host says, I'm going to reveal one of the booby prizes. Now, in this, we're going to do all scenarios. So, there's two strategies, right? Two strategies. And there's 3 scenarios in each strategy. So, there's a total of 6, if you want to do that with the ends, there's exactly 6 possible outcomes in the game. Exactly 6, right? There's 3 outcomes for 2 strategies. So 6 outcomes in total, right? So we'll do the first of 6. We'll do every single one, and then you'll see. Once you see all 6 of them, it's very clear, right? So we pick this as an hunch. A. He says, pick one at random. You say, I'm going to pick A as an hunch, right? Now, he reveals one of the booby prizes. So he says, right, that's the booby prize, okay? You pick this as an hunch. Now he says, you're going to stay swap. Now we're doing strategy 1, which is where you stay. So, you pick A, he reveals the booby prize, and you stay. Doing strategy 1, right? Stay. Okay? So, he reveals, forgive me, you pick A, he reveals the booby, he says, do you want to swap? You say, no, I'll stay. So, you stick with the one you hunch with, you win. Okay? Right. Now let's do second strategy, right? Second outcome. You're doing the strategy where you stay, okay? So you pick B as a hunch. And the game host says, I'm going to reveal booby prize. He reveals a booby prize, right? You say, I'm going to stay with my hunch. And then you lose, all right? You lose, okay? Now, this is outcome 3 for strategy 1, yeah? Right? You say, I'm going to do C as a hunch, right? The game show host reveals B is a booby prize, and you say, I'm going to stay. So you lose, right? So let's go over that again. Strategy 1 is where you stay, okay? So, you pick A as a hunch, he reveals one of the booby prizes, this one. You say, you stay, you win, right? You pick B as a hunch, he reveals a booby prize, right? You stay, and you lose, okay? C, you pick C as a hunch, game host show reveals the booby prize, you stay, and you lose, right? One more time. Choose, booby prize, stay, win. Choose, booby prize, stay, lose. Choose, booby prize revealed, stay, pick the original, you lose. So that was 2 losses and 1 victory, right? So if you do the strategy where you stay, yeah, where you stick with your hunch, the only way you can win is if you happen to pick the correct one by chance, right? The only way, if you stay with your original hunch, the only way you can win is if you happen to pick the correct one. So there's 2 ways you can lose and 1 way you can win. The only way you can win is if you happen to pick the correct one. Now, let's do strategy 2, right? Strategy 2 is where you swap. So, let's say there's 2 strategies and there's 3 scenarios for each strategy. It's totally 6 outcomes, right? Strategy 2, you always swap. So you pick A by hunch, right? One of the booby prizes is revealed. And the house says, stay a swap. You say, I'm going to swap because I always swap. Right, now you lose. That's 1 loss, alright? Okay. So, you pick B. This is the second scenario. You pick B as a hunch. One of the booby prizes is revealed. And he says, are you going to stay or swap? You say, I always swap. I'm going to go with this one. And you win, right? Then C. The third scenario. You pick C as a hunch. The booby prize is revealed. Stay or swap. You say, I always swap. And then you win. So let's do that again. So, 3 scenarios. We're using the second strategy where you always swap. Right? Hunch. Booby prize revealed. Swap. Lose. 1 loss. Hunch. Booby prize revealed. Because remember, the game host always has to reveal a booby prize. Right? So, hunch. Booby prize revealed. Swap. Always swap. And then you win. Right? And then hunch. Booby prize revealed. Yeah. Always swap. You go with this one. And then you win. Right? So, that's hunch. Reveal. Swap. Forgive me. That's hunch. Reveal. Swap. Lose. Hunch. Reveal. Swap. Win. Hunch. Reveal. Swap. Win. Yeah? So, if you do the strategy where you swap, right? If you do the strategy where you swap, because you always reveal a booby prize, the only way you're going to end up not swapping to the correct one is if you happen to pick that the first time, right? So if you do this strategy where you always swap, second strategy where you always swap, right? The only way you can lose is if you happen to pick this one correctly by chance. Yeah? So if you always swap, the only outcome in which you lose is where the booby prize is revealed, and then you swap, right? And then you get the booby prize anyway. Yeah? Whereas if you do the strategy where you stay, the only way you can win is if you pick the correct one, yeah? So if you always stay, the only way you can possibly win is if you happen to pick this one. And if you always swap, the only way you can possibly lose is if you happen to pick this one, right? So that's why if you always swap, you're twice as likely to win, yeah? Which is crazy. So that's, in my opinion, that's the way that helps me understand it, you know what I mean? Is that formulation. If you do the strategy where you always stay, the only way you can win is if you pick the correct one by chance, right? That's the only way you can possibly win. Because there's a 1 in 3 chance you'll pick it, obviously. If you do the strategy where you always swap, the only way you can lose is if you punch this one, and then booby prize is revealed and you swap. That's the only way you can lose, because, again, if you do the strategy where you always swap, as long as you don't pick the right one, you pick this one, the game show host has got to reveal a booby prize, right? So, because you're swapping, right, it's more likely than not that you picked a goat or a penny or whatever it is, right? It's more likely than not you picked the shitty prize, right? Because there's 2 of them, there's only one of the good ones, right? So, as long as you pick the shitty one, as long as you don't pick that one by chance, as long as you pick this one, when you get to the 50-50 at the end, right? As long as you didn't pick that one, when you get to the 50-50, you're always going to swap and get the right prize, right? Because there's 2 options for picking shitty ones. You pick this shitty one. So I'm hunching this one, right? This one is revealed. Yeah. You know it's not that. And you say you're going to stay swap. So you always swap, and then you win. Yeah. So then say you pick the other one, right? Ooh. Jesus. Say you pick the other one, right? So, literally, pick that one before. Say you pick this one. The booby prize is revealed. Yeah. So you think I'm going to swap. Don't go on your pick. Go on you swapped, and then you win. Yeah. So the only way you can lose, the only way if you swap, the only way you can lose is if you happen to pick that one. Yeah. The only way. Obviously, if you stay with your hunch, obviously the only way you can win is if you happen to pick this one. So if you always swap, if you do the second strategy where you swap, the only way you can lose is if you pick that one by chance. It doesn't matter what order they're in, obviously. I may look like that's the first one, it doesn't matter. It'll be any order, right? It doesn't make any difference, obviously. You know? The only way you can possibly win if you stay with the one you picked is if you pick the correct one. The only way you can possibly lose if you swap is if you pick the correct one. Yeah? So, if you stay with the one you picked, there's a 1 in 3 chance you pick the right one. Yeah? If you always swap, there's a 1 in 3 chance you pick the right one. Meaning there's a 2 in 3 chance that you'll end up. There's a 2 in 3 chance you pick one of the wrong ones, right? And as we showed, if you pick the wrong one by hunch, the other wrong one's revealed, meaning the third option left is the right one. So there's 2 out of 3 outcomes with this strategy, whereby you can end up in a final section of the game where you've got 2 things left, in the one that you didn't hunch is the right one. There's 2 ways. If you stay with the one you got, there's only one way. There's only one way you can do it and be guaranteed to get the right one, is if you happen to pick it. There you go.